Hello, hello Cloudwings, welcome back. So yesterday we have learned container lifecycle and all about the containers, dockers, images, and also we have learned most important topic which is container restart policy. And today we are going to see DevOps networking. So let's guys start. For who for whom not watching these video in sequence in playlist, I highly recommended those you. If you not going to watch the video one after other, then you will be missing something. You will may not understand the concept clear guys, because whatever video I'm going to delivering to you guys, these videos for freshers, non-IT guys, and who are doing the DevOps job currently, and person who is related to the cloud engineer roles and all the about the role which is either belongs to the DevOps. Everyone can join and watch this video and understand the networking, because today I'm going to show you the DevOps networking. These networking concept, if you are going to learn from a network administrator, they will take this much content of teaching to you around 1 or 2 months. But today we are going to complete everything in just 1.5 hours guys. So I again repeating, if you are freshers, if you are beginners, and if you are intermediate and advanced, these video for you guys. So let's see networking. So here is, we have the OSI model. Hope you all are able to see my screen. On my screen there is a OSI model, right? So guys, you are thinking, right? You may think, why I am teaching the OSI model? Why I have taught you the operating system? This video is belongs to the Docker. Then why we are learning these topics, right? So because after these we are going to learn the Docker networking. So I don't want to नहीं चाहता कि आप लोग बीच में ही छोड़ के चले जाएं, क्योंकि अगर आपको डॉकर की नेटवर्किंग समझनी है, so then you have to understand the networking concept. So basically we want to learn how the message, videos, content will be flow over the network. So in order to understand that, we have to understand the OSI model, right? So what is the OSI model, right? So OSI stands for Open System Interconnected Model. Open System Interconnected Model, right? This model is having 7 layers, and this model is going to tell to you how your message is going to deliver from sender to receiver. So because of that we are going to learn OSI model. So layer 7 is the application layer, right? Layer 7 is the application layer, and layer 6 is a presentation layer, right? I will tell you and I will give you an example. After that you will understand everything. Just see this video till the end, because you cannot understand video if you go and skip the video. I highly recommended the video. I highly recommended watch the video from start to end. Then only you will be understand. So layer 5, this is the session layer, right, which will maintain the connection sender and receiver, between the sender and receiver. TCP is what? It is also a layer 4. And layer, then we have the network layer, then we have the data link layer, then we have the physical layer. So all top three layer people called software layer, and top bottom layer people call hardware layer, and middle layer people call heart of the OSI, right? OSI, open systems interconnected, right? So to make you understand these 7 layers, I am having one story for you guys. So there is lover, right? There is lover. I bring you a story for you to make you better understand. That's why I'm bringing you a story of the girlfriend and boyfriend. So there is a lover, right, whose name is Jamie and Lily, right? So Jamie and there Jamie and Lily loves each other a lot, right? So on the Lily's birthday, Jamie think, I will write a message and I will wish Lily, right? So he write a beautiful message, right? Like, hi Lily, happy birthday to you, right? And better life, like something like he wrote the message, right? So he sent the message, right? So he sent the message by which application? By using the WhatsApp application. He write the message and he sent the message. Now we need to see how this message travel, transmit, transmit through the internet, and from Jamie to Lily, how Lily will receive the message. To understand that you have to understand this OSI model, because this OSI model tells us how your message data will travel over the internet. So we have the message, and from that message we need to see how this message is going to travel or transmit over the internet. So Jamie and Lily both are using the WhatsApp applications. Okay. So the moment Jamie send the message, open the application, write the message, right? Application layer will be active. Application layer will be active. So he wrote some message and sent, right? So message, the moment he send, this is what the application layer, right? The message will come to the presentation layer. On that presentation layer, message will be encrypted because of the security reason, okay? Then message will come to the session will maintain Jamie and Lily connection, right? Jamie's device and Lily's device connection should be maintained, otherwise how message will be sent. So that's why the message, the communication and the connection and session should be the maintained. That thing happened at L5, right? So these 3 layers we call the software layer, right? Then message will come to the transport, TCP. On the TCP message, whatever the message will be packet. Think one thing you have to remember here, entire message is not going to packet. Instead, the message will be divided into parts, and small parts of your message will be packet. That packet will be packet and frame. That packet will take the sender, means Jamie, IP address and MAC address and data. Lily IP address and MAC address. Okay, so both thing he will maintain inside the packet. Then the packet will be sent to the network layer. So at the network layer, right, network layer will decide where data should have to send, right? Where your data packet should have to send, because over the internet there is a way, internet is very large, right? There is thousands of IPs, there is thousands of devices, right? On that network, where should have to send this data, which device has to send this data, so that thing we have to decide where at layer 3. So on that network layer, IP routing will be decided, right? What thing will be decided here? IP routing, right? So then data, right, a small packet of the data will be come to that network, and that packet is having the IP address of both sender and receiver. So by judging that, he will send the data to that, right? Now data will be come to that at the street. Now on the street there is a many houses, right? On that street there are many houses. Data should send to that house, or you can say data will be sent to the doorstep. On that door, on that house, there is a many members, many devices. The data has to deliver to that device, right? So how this will know, right, this is genuine device or not? So there is a MAC address. I already told you MAC address is unique address that is every device will be having, and it is issued by the when we have that is the NIC, right? Okay, okay, hope you have understood till now. Okay, so then data come to the layer 4, right? Okay, then data will send to the layer 1. On the layer 1, what happen? Here we have the cable, Wi-Fi signal, right? Any medium data is coming. Okay, any medium your data is coming. Now data should be transferred, right? This data whatever you have sent, the data is in what language? High level language. Now data have to convert into the low level. What is the low level? Binary language, 0 and 1 language, because machines wire signals only know the binary language. Okay, so data will be hand over to that that physical, right? How this happen? Because we have already learned the operating system architecture. There I have decided, there we have discussed about how the kernel work, what are the job of the kernel. If you haven't watched that video, please go and watch. I will share that video link on the I button. Okay, so now whatever the 7 step that we have seen, I have explained here. That 7 step is as of now belongs to whom? Jamie, right? Jamie. Now same step has to repeat for whom? Lily, right? Because the sender is whom? Jamie. Receiver is whom? Lily. Now Lily doesn't know that message. Lily doesn't know the low level language. Lily doesn't know the binary number, right? Lily device doesn't know, right? Now the data is coming to the Lily's device. Now the reverse process will be happen, right? Again, whatever the message is going to convert to the binary, that binary packet will be sent to whom? Data link layer. Here data will be having MAC address. He will see, okay, this MAC address is belong to me. Then he will check the IP address. Okay, IP address also belong to me. Okay, then data will be transferred to the next layer, where layer 4. At the layer 4, TCP transport, it will maintain the data, because on the TCP we have two types of port, TCP and UDP. At the time of when we learn the TCP model, there we will discuss what are the TCP UDP. And for you have for your understanding, I'm just touching this part. TCPs will acknowledge, UDP will not acknowledge. TCP is slow, whereas UDP is fast. TCP is recommended to file and message transfer. UDP is recommended for the videos. Because of that, the UDP is fast. Okay, so TCP, now the data packet will come to the TCP. TCP will take the data and give. Again, session will be maintained, and on the presentation layer, data will be, instead of encrypting, because of the data is reverting, now data will be decrypt before delivering to the Lily's application, right? Now data will be decrypted. Now the message, again 7th layer will be come, the data whatever the decrypted, that message will be delivered to the application, right? Application, right? Lily's application will take that message, and after that Lily will be able to see the, oh yeah, I love you. Then Lily will also repeat that message, I love you too, right? So this is for the story, guys. how our message data will travel over the internet. If you understand this story, I hope you will never forget ever this story. And if you remember this story, that means you have understood the OSI model. Now let's next we need to understand the IP addressing, right? I gave this name 0 to hero because of I'm going to explain everything related to network, right? If you go and learn these much concept with a Linux administrator or network administrator people, he will take 1 or 2 months to teach to you this, okay? But here you will going to understand this much very important concept just in 1.5 hours. So what is exactly the IP address? So the IP is Internet Protocol address, is unique number assigned to a device or network used to identify it and deliver to data from sender to receiver. As I already told you, right? So IP address is what? It is a unique number. What is IP? It is a unique number that is delivered to with device, right? IP address is what? It is a unique number that has to deliver to a device. Every device is having the IP address. Without IP address, the device cannot communicate. Okay, that's why the device is getting the IP address through the network in order to communicate over the network. So deliver data from the sender to receiver, right? Why we need the IP address? IP address is need because we want to send data from one device to another device, right? And we have to make sure that whatever data we are sending, that should send to that person, right? Data should not like I wrote one message, Jamie write I love you message, so the message should has to send his girlfriend, not his wife, not his other girl, right? So that whatever that thing, that why maintained by this IP address. Okay, that is what the IP address. Now come to the octet. What is the octet? An octet is what? Group of bits. Okay, group of bits, right? So in one bit, how many bytes? Do you know? In one bits, how many bytes? In one bits consist 8 bytes, right? And 1 byte means what? 10101, total 8 bytes. 1 bits contain 8 bit, and 8 bit means they are binary number 0 and 1, right? Binary number means what? The machine language, machine can understand. Okay, so IPv4 is having 4 octet, right? IPv4 is having 4 octet, right? So 8 plus 8 16, and 16 plus 8 is 24, 24 plus is 8 is 32. So IP address is a sequence, that's why we are telling the IP address is what? 32-bit address. IP address is unique number, that is 32-bit number, right? That is assigned to a device, right? That is identify the sender and receiver. Okay, so because of that octet, don't forget this octet. Then come to the subnet. What is subnet? Don't worry guys, in upcoming slide I will make you clear whatever you want to understand, right? Because if you when you will learn the Docker containers, all these things will be the virtualized. So if you not understand these things here, then you will be definitely confused there. You will be not understand anything at all, right? So that's why I'm going to show you these concept. So don't skip the video and don't try to skip the video. Okay, so just understand the whatever I'm teaching you. Okay, so the subnet mask is what? 32-bit number that tells which part of the IP address is network and which part is the host, right? So subnet mask will tell you, right? If you use the subnet mask, right, we will understand in the upcoming slide what is the class CIDRs and what are A, B, C, right? What are the class CIDRs? So there you will be understand more better the subnet mask. So here just understand the subnet mask. What it is tell to you which part is the host part and which part is the network part. Now come to the MAC address. MAC is what? Media access control address is a unique and physical address assigned to a device network interface, NIC, used to communicate inside the local network. How it looks like, you can see the format. So every computer, right? So early when we have the computers, so NIC card we has to buy and we has to attach to our device in order to communicate over the internet, right? Without the NIC card, your computer cannot connect with the internet, right? So NIC card is very very important. This nowadays, if you go and buy, if you go and buy the laptop and PC, right? So you will be get this NIC card inbuilt on your motherboard. You will see this NIC card has inbuilt already. So here, this is what the MAC address, right? So every device is having the MAC address because of the NIC card. Now come to the next slide. Now we have to understand the classful interdomain and classless interdomain. Guys, many people get confused because they didn't understand the everything from the evolution point of view. I'm bringing everything from the evolutions. First, I will make you clear what exactly the classful interdomain routing, and then I will clear the what is the classless interdomain routing. If you understood all these two topics, then definitely you will understand the entire network, right? 78% of the networking you have to complete it. You no need to learn from these things anywhere, right? So what exactly the classful interdomain routing? So classful interdomain routing is the old IP routing method where networks were identified using fixed IP addresses A, B, C, right? These are the classes with default subnet mask like /81624 without carrying the subnet mask in the routing updates. सो ये क्या होता है, आपकी जो क्लासेस होती है उसको उसका क्या होता है, डिफॉल्ट फिक्स्ड वैल्यू सबनेट मास्क देता है, राइट? सो क्लासफुल में क्या होता था, फिक्स्ड सबनेट मास्क होता था, ठीक, फ्लेक्सिबल नहीं होता था जितना इसमें फिक्स होने की वजह से आपको नेटवर्क एंड होस्ट आईडी फिक्स मिलते थे, राइट? सो आफ्टर दैट वी हैव द क्लास लेस इंटरडोमेन राउटिंग, विल सी इन अपकमिंग स्लाइड. ओके, फर्स्ट अंडरस्टैंड दिस. So if we talk about the class A, what is the class A, what is the class B, what is the class C, right? So in front of you we have the octet. IPv4 is having 4 octet. Every octet is having 8 bits. Okay, so like from class A, to identify a class, how we can identify from its range? You can identify class A from its range. Its range is starting from 1 to 126 and 0 and last 127 is reserved, right? 0 for host and last IP is for what? Broadcast. Okay, and its default submask is 8, right? So if you calculate, it's like 32 minus 8, you will get 8, and approx its mask you will see the 255.0.0.0, right? This is what. So in this case, in this is going to be very large, right? This kind of setup can handle entire big city network, right? Approx 60 millions of host device you are going to see per network. This is how big network you can think, right? In this case, your first octet is going to fixed for networking, remaining for your host top, right? So this is how big you can think. Then we have the class B. This is a medium network, right? Its range starting from 128 to 191 and its default mask is 16, right? Guys, understand this classful. In this case, what happening is here, classfuls are the fixed, classful is in the fixed subnet mask, right? There is no flexibility, right? There is no flexibility. Whatever the fix we have to use, right? Even you don't know this much network and host you have to use, right? That's why it get deprecated. Okay, people are not using this, right? People are using classless interdomain. We'll see in coming slide. So the default mask is 16 and for its you will get first 2 octet will be for networking and second for host. right? And approx you will get the 65,534 host per network. Okay, remember this, host per network. You are going to same thing, you will have the class C, and right in this class C you are going to see the 254 host, and first 3 octet is going to assign for your network, and last 4 is for your host, right? So 254 host per per actually this is the usual IP, right? 254 usual host each network you are going to get if you use the class C, but not people are not using this. So here you can see the class A is for large network. If you need create a large network, you can go with class A. If you need medium network, you can go with class B, and if you have a small network, you can go with class C, right? So this is what the classful interdomain routing, you have to understand this. Next we have to need to understand the what is the classless interdomain routing, right? So classless interdomain routing is a method of IP addressing that uses two prefix like 24 to define the network size and allowing efficient IP allocation and routing, right? So this is allowing us the efficient way of defining the IP, right? Instead of 24, you can give your desired number between below 20 32, right? Any number you can give. If you are going to work on the AWS cloud, there is a limit, there is a CIDR will be start from the 28, right? So that thing you can consider. So here what exactly the class interdomain routing, this is what, right? So here we need to understand the subnetting. Subnetting is the process of dividing large network into the smaller network. What is a subnet? It is the process of dividing a large network into the smaller network, right? So subnetting is what, subnetting and classless interdomain are both are same. They are दोनों ही क्या है, एक सिक्के के दो पहलू हैं. सबनेट पढ़ लो चाहे साइडर पढ़ लो, दोनों सेम. अगर आप क्लाउड पढ़ोगे तो वहाँ पे आप देखो, इफ यू आर गोइंग टू लर्न द AWS GCP and Azure, there you will be see the CIDR, right? So subnetting mask you are giving with the CIDR, right? CIDR जैसे कि आपके पास एक एग्जांपल लेते हैं. यहाँ पे आप एग्जांपल में ये देखोगे कि मैंने एक IP लिया है 10.10.1.1, राइट, एंड /24. यहाँ पे /24 क्या है? /24 एक नोटेशन है. व्हाट इज दिस? एक नोटेशन है जो कि डिफाइन करता है योर आपके साइडर को, राइट? सो /24 is going to define your notation in CIDR, right? It will define your range. अगर हमने IP को 24 दिया तो 32 minus 24 how much? 8. You will get the 8. and 8 को आप तो होस्ट पर नेटवर्क कितने आएंगे? 2 power 8 is equal to 256 minus 2 because first is for network and last is for broadcast. So 2 IP will be minus. So total usual IP you will get 254 per network, right? 254 per network IPs you are going to run. These much device you can run on single network, right? This is the recommended way of creating whenever if you are learning AWS, there you learn the VPC. On that VPC you have to understand these topic, otherwise you will not able to create the network. If you want to deploy your own network, you have to understand all these concepts, then only you will be able to deploy the internet, deploy the VPC network on the cloud. Okay, so what advantages we have with these? So over this we have the advantages like network management easy, right? Because there is a fixed network, but here we have everything is in our hand. We can give any CIDR, right? Below the 32 if IP is v4. Okay, so security also has improved and broadcast traffic कम होता है इसके अंदर, right? and IP wastage कम हो गया है, right? and performance better हो गया है. Okay, so this is what the CIDR. So hope you have understood today's video, guys, and today I have explained everything about the networking. If you haven't understood the video, please watch it again and again, right? If you understood this video, then you are ready to go work with the Docker networking. So in upcoming lectures we are going to learn the Docker networking. I will tell you each network, and also I will tell you the practical demo of the networking. So hope you have enjoying this video and you keep learning, keep smiling. Please thumbs up, like and share. We have give a lot of effort to making these kind of videos. We need just your like and share. Please like and share and subscribe. If your one like give us what? Motivation. So we need just from you motivation. You cannot buy a coffee for me, but you can like and share and subscribe. Thank you, thank you, thank you.